Okay, so today we are going to learn a little bit about the chemistry of life. It all comes down to chemistry. Now, for some of you, this might be a little bit of a review, but it's good just to kind of remind ourselves of some of this material. And for those of you who it's new, well, this is some things that you need to know. So let's start then. So, chemistry begins with atoms. I think most of us know that. So we're going to talk a little bit about what an atom is and how it is, what it's composed of. Atoms are the basic unit of matter. So what do we mean by matter? So matter is what makes up all things in the universe. Everything is made of matter, whether it's the iPad that you're looking at or the finger that you're using to press on the iPad, everything in the room, the air you breathe, your dog, everything is made of atoms. It's the basic unit of matter, and even though you can't see them, they are there. So they're very tiny. So if you place them side by side, it would take about 100 million atoms to make up a centimeter. So a centimeter is probably less than the width of your finger. So that's 100 million atoms. That gives you an idea of how tiny they are. And they contain subatomic particles that are even smaller. Do we know what they're called? I bet you do. You've learned this before. And you're right, they're protons, neutrons, and electrons. Now, this is a picture of an atom. Now, atoms, of course, don't really look like this. This is how we might depict an atom if we drew a picture of it. And we show this is the atom helium. It's number 2 in the periodic table. And we show that it has protons, neutrons, and electrons. The protons are represented by the blue with a plus. The neutrons are purple, and the electrons have a negative symbol or a minus sign, and they're sort of on the outside, orbiting like little planets, even though that's not really how they are. This is helium. It has an atomic number of 2 and a mass number of 4, and we'll talk about what that means in a minute. So we have protons, neutrons, and electrons. So let's talk about protons and neutrons for a minute. Protons and neutrons have about the same mass. Now, we should probably talk a little bit about the difference between mass and weight. I think I might ask the class that question, so think about that. What is the difference between mass and weight? They are positively charged particles. They have a plus sign. So think about batteries that have a plus sign or a negative sign. Protons are positively charged. Neutrons have no charge. Neutron meaning neutral, no charge. And they're about the same size as a proton, but they have no charge. And they're bound together in the nucleus. The protons and the neutrons are bound together by very strong forces. And they form what's called the nucleus, which is at the center of the atom. Now, this is different from the nucleus of a cell, which we will talk about later on. But the nucleus of an atom is that represents the center of the atom. Again, it's made up of protons and neutrons. Let's talk about electrons for a second. They are negatively charged, whereas protons are positively charged, and they have very little mass, 1 over 1840th the mass of a proton. That's sort of a silly number, but it's just to show you that they have very little mass, and their mass is almost indetectable. But they are there. They are in constant motion in the space surrounding the nucleus. Matter of fact, it's difficult to know exactly where an electron is. It's more like a cloud around the nucleus. And they're attracted, they're negative, and they're attracted to the positive charged nucleus. But they don't fall into the nucleus because of the energy of their motion. So they're moving really fast. Just think about the Earth circling the sun. The Earth is attracted to the sun by gravity, but it doesn't fall into the sun because of the energy of its motion. Same with the moon. The moon doesn't fall onto the Earth because of the energy of its motion. So again, positive protons attracting negative electrons. Opposites attract. Probably heard that expression. So that kind of gives us an overview of protons, neutrons, and electrons. So I'm hoping that's a review for you. Now let's talk for a second about elements. A chemical element is defined as a pure substance that consists entirely of one type of atom. So elements are represented by one or more two-letter symbols. So for example, C stands for carbon. Carbon is an element. It's a pure substance. There are only carbon atoms. You cannot have any other atom and call it carbon other than carbon atom, and it has a specific number of protons and electrons. If it doesn't have that number of protons and electrons, then it's not carbon. And Na stands for sodium. So we have 1 or 2 letter symbols that represent these elements. Excuse me. Every element has a unique number of protons, neutrons, and electrons. So what that means is, like I said, carbon has 6 protons and 6 electrons, and if it doesn't have that many, then it's not carbon. The number of protons in an atom of an element is the atomic number. So when we look at the periodic table, you'll see those numbers. The atomic number is the number of protons, which happens to equal the number of electrons. And again, use carbon as our example. Carbon has 6 protons, so its atomic number is 6. Now there's more than 100 elements known, but only about 24 are commonly found in living organisms. Now this is our periodic table. This is a great resource. I put it on Schoology under the Files section, so you can print it out if you want a paper copy, or you can use the file here. I've also given you an iPad app that has the periodic table on it, but let's take a look here for a minute. You see all the letters representing all the names. The names are up here in the top, so here's hydrogen. Its atomic number is 1, meaning it has 1 what? 1 proton, right? And its symbol is H. And we can move over to one of our favorites again. Here's carbon. The name is up here. Its atomic number is 6, so it has 6 protons. And it also has an atomic mass, which is 12.011. I'll describe what that means in a few minutes. So we've got nitrogen, oxygen, fluorine, neon, okay? And these are all organized by their characteristics, and you'll learn a lot more about that when you take chemistry next year. So, the periodic table contains very important information about the element, obviously. It's got its symbol. Here's K. And sometimes the symbol doesn't match the name. So in this case, K, it stands for potassium. Well, K was actually the start of the original name for this element, which I don't know, but K is the symbol for potassium. Pb is the symbol for lead, and that's because the Latin word for lead is plumbium, which is where we also get the word plumber from, because pipes used to be made from lead. So sometimes you'll see these odd symbols that don't match the name. Then you have the atomic number, again, number of protons, which is equal to the number of electrons. You have a mass. Now, the total mass is the number of protons, 19, plus the number of electrons, and the number of neutrons. Now, remember, electrons don't have much mass, so they don't account for much. Probably this 0.0938 here represents the electrons. And the total mass is the mass of the protons and neutrons and the electrons. There's mass number. We're not going to worry about that here. We won't be using that. But the important point to make here is that the number of protons does not always have to equal the number of neutrons. So if this element has 19 protons, and if it had 19 neutrons, then the number here would be 38. But it's 39, so it has an extra neutron. Now, and we'll go into this more when we practice this during class. Now, there's a few elements that are very important for living things. Now, a lot of teachers use different acronyms or different mnemonic devices to remember this. This is the one I use. We say SPONCH, S-P-O-N-C-H, cafe. And that helps us remember these elements that are critical for living things. Sulfur, S for sulfur, P for phosphorus, O for oxygen, N for nitrogen, C for carbon, H for hydrogen. Those are the main elements. And then we have a few others like calcium and iron. Fe stands for iron. And there's some others we'll learn about too, but these are the main ones. And really what I want you to remember is this SPONCH business, and know that sulfur, phosphorus, oxygen, nitrogen, carbon, hydrogen are the primary elements critical for living things. And all living things contain this one, carbon. We are carbon-based life. And carbon has some very special characteristics that enable it to be so important. So if you want to get out or open up a periodic table on Schoology that I've put out there, you put it in Note anytime, and you can highlight these that are on the periodic table. We can probably do this in class, but you might want to do this too. So just open up that file that's in the folder called Chemistry of Life. There's a periodic table there, and you can highlight these using Note Anytime or whatever you want to use. So that's about it for this little video. Next we'll talk about compounds and molecules, and we'll talk about chemical bonding and how that works. But I think for now we're just going to stop here, and you can rerun this video, stop it where you might need to, and then you can take the little quiz that's in Schoology that shows me that you've had a chance to read this. Okay?